if we were to look at a circle, any circle, with the origin, with the center at the origin, and we were to draw a right triangle, where the hypotenuse is the radius, and identify this is my angle, then this is going to be the adjacent side, this is going to be the opposite side, and this is going to be the hypotenuse. The hypotenuse will be equivalent to the length of the radius. So if we think back to our trig ratios, sine is the opposite over the hypotenuse. The opposite side, since this is a point, we'll label it just in general xy. Since the opposite side is the vertical distance, which is equivalent to our y-coordinate, then the opposite side is going to be the value of y over the hypotenuse, which is r. That's this value here. Sine is y over r when we're looking at the point on the circle. And we overlap that with our triangle so we can see where this is coming from. Our cosine is the adjacent side over the hypotenuse. The hypotenuse is my radius, which is r, and my adjacent side is my horizontal distance from the origin, so that's going to be my value of x. So that's where they're getting x over r from. Tangent is going to be opposite over adjacent, so that's my y value over my x value, because that's the vertical distance from the origin over the horizontal distance from the origin. And then using our reciprocal identities, we can get the rest. Now, if we have the unit circle where the radius is 1, when I look at the sine is y over r, that r is 1 now. So I just have the sine is y. Y over 1 is just y. Anywhere in these definitions above where you see r, you can replace it with 1. So that's why the cosine of your angle is x. It doesn't affect the value of your tangent because you don't have r's in your tangent. And it doesn't affect your cotangent because you don't have r's there. But it does affect your cosecant. Cosecant and sine are reciprocal, so you just take 1 over y. And secant and cosine are reciprocal, so secant would be 1 over x. So when your circle has a radius of 1, your hypotenuse is 1. And that's the relationship between these two blue boxes. The blue box on the top is for any circle of any radius. So if we had a circle of radius of 2, we would want to make sure we put in r as 2. If we have the special case where we have a radius of 1, then we can use this second box down here. Later, when we start graphing these, we need to be familiar with the domain and range for sine and cosine. So for the domain, and this is for both sine and cosine, the domain are the values that you plug in, your inputs. So I would plug in my angle. I can plug in an angle that is negative. I can plug in an angle that's positive. I can plug in a 0 angle, whether it's 0 degrees or 0 radians. I can plug in fractional degrees. I can plug in a half a degree. I can plug in the square root of 3 degrees. I don't have any restrictions on the degrees or the radians that I plug in. For the sine and cosine, the domain for both of those is going to be minus infinity to infinity. I can plug in anything I want. However, for the range, when we look at the unit circle, the value of my cosine and my sine are going to be my x and y values. So the smallest value that I can get out would be -1. And the largest value I could get out is positive 1. I can get in anything in between. I'm not going to get out a -2. I'm not going to get out a +5. That's impossible because these functions are defined based on the unit circle where you have a radius of 1. So for example, this point right here is the point 1, 0. And this point right here is the point 0, 1. This point right here is the point -1, 0. And this point right here is 0, -1. This is the smallest value you could get for y, and this is the biggest value you could get for y. That's -1 to 1. This is the smallest value you'll get for x, and this is the largest value you could get for x, from -1 to 1. So for both the sine and the cosine, these are both your range and domain. To evaluate trig functions, remember, trig functions, so you plug in an angle, you get out a ratio. When I look at the unit circle, the angle is 7 pi over 6. That means I open 6 pi over 6, which is pi, and then another pi over 6. If I look at the unit circle, it's 7 pi over 6. This terminal point would be -√3/2, 1/2. Since I'm asking you to find the value of sine of 7 pi over 6, sine is the y coordinate of the ordered pair. So this is going to be 1/2 because that is the y coordinate. Now if I asked you for the cosine of 7 pi over 6, then you would say -√3/2. Now you can check this on your calculator if you'd like. Because the angle is given in radians, and we know that because it doesn't have a little degree symbol up there, make sure you're in degree mode on your calculator and hit the sine button, and then in your parentheses put 7 pi over 6, and you'll get 1/2. For part B, it says cosine of 17 pi over 6. So if we look at the unit circle, 18 pi over 6 would be 3 pi. Pi over 6 short of 3 pi. So if this is my initial side, I'm going to open 1 pi, 2 pi, and then almost 3 pi. I'm pi over 6 shy of 3 pi. So that's going to be the same as this point here using my reference angle. That's going to be the same as pi over 6 on my unit circle. And at pi over 6, my ordered pair would be the √3/2 and 1/2. So this point over here that we're looking for is going to be -√3/2, 1/2, because it's in the second quadrant. So this is asking for the cosine of 17 pi over 6. Cosine is my x value. And so my x value would be -√3/2. So my answer to this question, if I open up 17 pi over 6, and I use my reference angle of pi over 6 to find my terminal point, then I look at the corresponding x value for that, and it's -√3/2. You can check it in your calculator. If you make sure you're in radians and you put in cosine of 17 pi over 6, you're going to get the decimal approximation for -√3/2. For part C, it's 7 pi over 6. We already found the angle in part A for 7 pi over 6. Here's my initial side. 7 pi over 6 is 1 pi over 6 past pi. So here's pi. I swing open to pi, and then I go 1 more pi over 6. So my reference angle is pi over 6, but we already used that to find my terminal point. And the terminal point we found for that in part A was -√3/2 and 1/2. Now, the tangent is your value of sine over cosine. Since sine is 1/2 and cosine is -√3/2, I take 1/2 divided by -√3/2. I cross off my 2's, And my final answer is going to be negative 1 over the square root of 3. I can rationalize that if I want and make it negative square root of 3 over 3. Either way, this is my answer for tangent. You can check it in your calculator and get the decimal approximation. Your calculator won't give it to you in exact mode because it can't do irrational numbers in exact mode. Okay, part D, negative pi over 3 means that I'm going to be sweeping my angle open in the clockwise direction. So I have my initial side, and I'm going to sweep open negative pi over 3. That's going to be this point here. At this point on my unit circle, it's going to be positive 1/2 and negative square root of 3 over 2. Since we're looking for the cosine, I'm going to take my x value, and I'm going to get that that's 1/2. Secant of negative pi over 3, that means I'm looking at the same angle. So here's my initial side. I swing open. Here's my terminal side. My point on the circle that it intersects with is 1/2 negative square root of 3 over 2. Secant is the reciprocal of cosine. Cosine at negative pi over 3 is 1/2. So I need to take the reciprocal of 1/2 and get 2. So my answer for this one is 2. Last one, it's the same angle again, negative pi over 3. So here's my initial side. I swing open, negative pi over 3. My point on the circle is 1/2 negative square root of 3 over 2. Cotangent of negative pi over 3 is the value of cosine over sine. So I want to take cosine, which is 1/2, and divide by negative square root of 3 over 2. I can cross off my 2's, and I'm left with negative 1 over the square root of 3, which I can rationalize if I want. Okay, last two examples. We are going to use our identity, sine squared theta plus cosine squared theta is equal to 1. This was in the box, the shaded box that we had when we looked at our reciprocal identities. There were two other Pythagorean identities in there, but we don't need it for this example. But this is very important, and we'll use this formula quite a bit as the semester goes on. This is derived from the Pythagorean theorem. So we're going to use the fact that we're given sine theta, and we're going to take negative 15 over 17 and square it, plus cosine squared theta is equal to 1. And the question is asking us to find cosine theta. So I just need to solve this equation for cosine theta. So I'm going to square negative 15 over 17, and that's going to give me 225 over 289. Then I'm going to subtract 225 over 289. Then I'm going to subtract 225 over 289 from both sides. So you're going to have to write 1 as 289 over 289 so you have a common denominator. And when you subtract from both sides, you get 64 over 289. When I take the square root of both sides to solve for cosine theta, I'm going to get plus or minus the square root of 64 over 289. So cosine is going to be plus or minus 8 over 17. Now, to decide which of these answers I use, plus or minus, that's where we use the quadrant. It says we're in quadrant 3, and in quadrant 3, both x and y are negative, so cosine is going to be negative. So my final answer is going to be cosine is negative 8 over 17. Okay, in this last example, it's very similar. we're going to use sine squared theta plus cosine squared theta is equal to 1 again. And we're given that sine theta is a half, so I'm going to plug in a half in for sine squared theta, and I'm going to solve this for cosine theta because the question is asking me to find cosine. So I'm going to square a half, and I'm going to get 1/4. Then I have to subtract 1/4 from both sides. So you're going to have to make 4/4, so you have a common denominator. And I'm going to get cosine squared theta is equal to 3/4. Then we're going to square root both sides to get cosine theta. And I'm going to get plus or minus the square root of 3/4, which can be simplified as plus or minus the square root of 3/2, because you can take the square root of 4 and then 2 is no longer under the square root. Now, to decide whether I use the plus or the minus, I then refer to the other information that they give us on where the angle is located. So if we look at our unit circle, I know 2 pi is after I make a full rotation. And this is telling us the angle is between 2 pi and 5 pi over 2. That's 2.5 pi. So 2.5 pi would be if I add another half pi to 2 pi. So I know that we're dealing with the first quadrant because it's between 2 pi and 5 pi over 2. In the first quadrant, cosine and sine are both positive. So my final answer is going to be that cosine theta is positive square root of 3/2, since I know we're dealing with the first quadrant.